Now is the turn of Florian. Yeah.
Okay. Hello, good morning. Also from my side, thank you for having me. I will share my screen. I hope you can see it now. Can you see my
Yeah.
screen? Yeah.
Yes, perfect. Thank you.
Okay. Thank you. Um, yeah, I have geared my presentation towards a bit more the applied science. But before starting this, when looking at these two pictures, this is a bit state of the art and even maybe a bit near future with automated trucks. So it's efficient, it's optimized. However, we face some problems, some disruptions. And Remunet has carried out a categorization of different disruption types. And I will focus in my presentation on transport delays and network breakdowns due to natural disasters. However, there are other disruption categories. You can have a quick look here. And for instance, the pandemic, we are all well aware of the impact and how the logistics was dealing with that. Going to my next slide. I've tried to list down for these disruption types effects on the operation. And yeah, for instance, the traffic situation. We are all aware of that this changes over day, but it can occur in different networks. So it can occur not in the road network, but it could also occur in a navigation network or at a rail network. So these are challenges to cover during the operational phase. There's also the possibility that if a certain vehicle breaks down or a time window can't be met, and there's also other mode-specific disruptions which can occur, like delay, cancellation, journey sequences changing, and so on. So how to deal with that? And we have in Remunet two interesting pilot corridors, which cross a number of 10T corridors. So one is the North Sea Baltic and the other one is the Rhine Danube. This being said, what we are doing is we split into a strategic phase and into an operational tactical phase. So I want to first focus on the strategic phase because this is somehow where the master planning takes place. Motivated by the physical internet concept, we identify and cluster potential modal shift categories for shipments. We identify then what are the relevant transport networks. Then we look into an analysis of the as is in regards to the transport demand into services and costs. Costs, be it monetary or ecological. So then we review what are potential future scenarios. So this means that the as is situation may change over time. So there can be adaptations of the as is situation, or there can be something radical in case some situation, the as is situation was that there was no intermodal at all. But there's in the future the possibility to generate enough mass. I come to this in a few seconds, and to go then intermodally. So the generation of critical mass for modal shift is, of course, a quite vital thing. And this is covered not in the technical work packages, but in the other process-oriented work packages, like Lars Klapper was explaining it in the talk before, towards collaboration between shippers, towards logistical nodes and lane managers, inside and also across companies. Once we have this is all, let's say, homework to be done before something happens. We have harmonization and an agreement of data and process interplay. There's a huge importance towards data and towards understanding of what is inside the data. So for instance, if there's a terminal, there's a different code at one operator and another code for the same terminal at a different operator. So this makes life difficult. Mapping has to take place, but you need to be well aware of that this is a situation. So what is the phase result? A strategic plan on the transport network layout, answering the questions, what are the main nodes, what are the main lanes, what is to be transported intermodal, and what is to be trucked. So now we come to the IT perspective. We have digital data support for the infrastructure. So we have a comprehensive list of terminals, of logistics nodes and hubs. There's also a digital map for different networks covering road, rail, inland waterway, sea, and also air. And we have the network connectivity. You see here only a snapshot of it. There's also more data linked to it. If you are interested in this, please feel free to reach out to me. So looking into the services. So the services are in our case timetable based or ad hoc services. So these can be lanes, information, frequencies, service days, time, cost, restrictions, operator name and contact. What you see here on the slide presented is a rail network. I have decided to take this as an example. However, in RemuNet, we also have the possibility to set up a relay network. So truck meets truck again, but it starts somewhere and it follows a certain lane, but either the trailer or even the full truck is handed over, and the truck driver returns then back to the home base and stays there also overnight. This is a concept we include also in the analysis and into the services. So how does this look like then for the user and for us as analyzer of the use cases? We plan transport routes. We plan alternatives for these transport routes in case something goes wrong. We calculate intermodal chains and we calculate these door to door. And if it is a intermodal lag, then there's likely at the beginning or at the end a road pre and post haulage. So these calculated routes, we can compare them and check what is most cost efficient, what is most ecological friendly, and what is maybe, in case of disruptions, an alternative which can compensate possible delay. We then go one step further and not only look into a specific route, but we try to set up an optimization for a network at large. So we have different transport orders. It could be maybe 100, 1,000 or 10 million. It would be possible. So therefore, the approach is we calculate per transport order possible alternatives. We optimize then the used services per transport order and allocate them based upon the potential capacity of the lane. We can optimize for cost. We can optimize also for efficiency. So these are tools which help out to the plan the strategic phase. Looking into the dynamic phase. So now let's assume we have got the network planned and our network is in production. So some transport orders are shortly to be transported, or some others are already in the transport process. So they are on the truck or at the train or on a ship. But all of a sudden, a disruption happens. A bridge breaks down, or a terminal catches fire and is out. And to cover these, what are your opinions? You have to ask yourself, what do you want to do? So likely do you decide that this is some disruption which will vanish within 2 hours, like a portal crane can be put to operations back again. Or it's a disruption which is quite severe, like a bridge collapses and you have huge dramatic impact on the whole network at that region. So therefore, we follow the approach. We have visibility of a network which is affected, and we have possibilities to interact then, following decision support processes. And last but not least, it's up to a planner or to a dispatcher to take the decision. Do I accept the system proposal or not? So in case of the execution, maybe you want to transfer to a different alternative route. So you want to detour that region where this event happened, or you just say, yeah, wait and sit it out. At the tactical phase, so prior the transport operation has started, you can consider different options. You can either shift the mode, so meaning book an alternative. You can take the disruption of risk. So you risk that the capacity maybe is decreased and you will face some delays. You can, of course, then also look into other options like cooperation with other stakeholders of the community. But this, on the one side, requires visibility, also in regards to capacities, and likely also towards prices. And of course, this has to be part of a strategic agreement to cooperate with different stakeholders in that community. So as a summary, on the strategic level, information is key, right? So this is no doubt about it. You need to know what is out there, what can you use, what is maybe new, and the network changes over time. And from time to time, it changes drastically. The strategic decision has to be done how to transport modally. So if you're a company which only drives trucks, then it's unlikely you want to switch modally. But over time, you may decide that you want to do a modal shift, and then you maybe lack the competence to do this. So then you need some help. And in case of Remunet, this tool set of Remunet can support this. However, IT tools can support planning, simulation, and optimization at large, right? So you can play through different strategic scenarios with these tools. And this is an important aspect. So you can calculate what is the effect of if the energy price increase next year for, let's say, road transport, or the toll for the road increases, or the energy price for rail transport drops next year. What are the effects? How efficient can I operate my network? Last but not least, the decision for the collaboration is often not done by the IT, but by the company management. What do I want to say by collaboration? Well, in case you have a lane, you may not operate this alone, but you may want to collaborate with other stakeholders of the community, like with a competitor maybe, or with someone who is just neutral to you. So this is not an IT-driven decision, but this is a management decision. At the tactical and operational level, disruptions occur across all networks, so there's no network taken out. But the impact of the disruption per network often varies. So if there's a delay in the road network, well, it's a very dense network. You can detour. If some bridge collapses, you can also detour this. If some event happens at the rail network infrastructure, like Rastatt event, then this has really severe impact. So this we need to keep in mind while planning out our networks. So a transportation desk managing and the transport has several options to react to the disruptions. So they take the decision if some disruption happens, whether to sit out or whether to take action. Last but not least, IT tools can support the analysis and can also support potential future alternative transport options. What I did not write into the summary, but what is quite vital also for the future, is the impact of AI and learning. So you learn from your daily operations, from your network designs, and this is something which will flow into the future, into the strategic, but also again into the tactical and operational level. So this was my last slide. If you have questions, please type them to the chat, or you can reach out to me via email. Thank you.
Thank you, Florian.